detection of toxic analytes and their biological application. Let us extend a warm welcome to Dr. S. Valamadi ma'am.
To preside over this session, we are honored to have Dr. S. Martin, Assistant Professor, Anandar College. Sir, we are delighted to have you as the session chair for this session.
Thank you. Good afternoon. All right. Most of the chairs are empty. I feel it is 100 chairs filled with your minds. Our college students are away. They'll come back. Okay. We'll start our program. Today we have eminent professor, Dr. S. Valamadi. I just brief her biodata. Received her PhD degree in organic chemistry from University of Madras in the year 2001. After her PhD, she received a postdoctoral fellowship from Japan and worked for 3 years as National Institute of Advanced Industrial Science and Technology. Currently, she is a professor in the Department of Chemistry, that is Organic and Polymer Synthesis Laboratory, National Institute of Technology, Trichy. She holds visiting professorship in institutes like National Institute of Material Science, Japan, and Busan, South Korea University, National Yang Ming Chico Tung University, Taiwan, University of Connecticut, USA. So she has worked all over the world, East, North, South. Received the Tamil Nadu Scientist Award. You can clap here for this. TANSAC 2020. CRSI Bronze Medal for the year 2023. Received the prestigious Tamil Nadu Young Woman Scientist Award 2012. We have also one more women's, our HOD also received 2014. For chemical science also received INSA Bilateral Exchange Fellowship 2015. She is an elected fellow of Tamil Nadu Academy of Science, Chennai, Fellow of Royal Society of Chemistry, Fellow of Indian Chemical Society. Her major research area of interest are asymmetric synthesis, chemosensors, and catalysis. To her credit, she has published 180 papers in highly reputed international journals. She has delivered invited lectures in many national and international conferences. She has received funding from various fund her guidance. Currently, 10 scholars are doing their PhD degree under her supervision. She is a member of American Chemical Society, Royal Society of Chemistry, life member in Chemical Research Society in India, Catalysis Society of India, and Material Research Society of India. We are very privileged and proud of you, madam. It is over to you.
With that, I now invite Dr. S. Valamadi to deliver a presentation. Over to you, ma'am.
Good afternoon, everyone. So your Martin sir told that there are many empty chairs, and he assumed that the chairs are filled with your minds. So I too assume the same, and it is really difficult to engage the students after a lunch session. Hope I will do the justification. So thank you, sir, for your nice introduction, and I thank Savita Devi ma'am for her invitation to this college. So before going into the technical session, I just want to give a small message for the students. You would have seen many conferences, and many resource persons might have come and gave many presentations. So what is the message that you have to carry from all of them? Is the chemistry that they have discussed, or something else? All have started their career as some college or other as an MSc or a BSc students. They also have come from places like very remote area where there are not facilities. But in their life also, some conference like this might have been a source of inspiration and a point of motivation. So they came to a higher level, and now they are nicely placed. If you see in the recently developed Indian Institute of Science Education and Research, most of the faculties are, if you see, they have done their MSc from, many from MSc from American College, St.Joseph's College, and then Madurai Kamaraj University. Those are all, they have gone for IIT or IIC Bangalore for their PhD, and now they are in a professor level in that. So the entire research community of Indian Chemical Society is in the hands of students, those who did their MSc in the college like this. So you should all take pride that you will also be one among them in the near future who will be shaping the science and chemistry research in India. So I always tell to my class in MSc or whenever I address a student, life is like a beautiful column. You all know that we will put column in the our doorsteps, which has lot of points. So similarly, your life also has many points. Today you may not think that this is whether this is an important point or not an important point. But all points are important, and they may be a turning point also in your life. So let us all try to develop a nice column by joining the dots that each day the God is placing in our life. Okay. So I am going to talk about donor, pi acceptor and other things. Before that, the research that we are carrying out at NIT Trichy, we do a lot of different aspects of research. Mainly 3 or 4 major branches we are dealing with. One such important thing is developing small molecules for sensing applications. So some of the important papers that we have published is listed here. And also we do develop a lot of nanomaterials and molecules that absorb in the near infrared windows, which is having a very good bio application. It's live cell imaging and so on. And earlier we were doing, some part of the group is working on organic synthesis. And in that process we developed some new materials like mesoporous materials and metal organic frameworks for applying as catalyst for these organic synthesis. So most of them are interrelated. So whatever catalyst we want, we develop and apply them as some of the catalyst in many organic transformations. And some of the molecules, if they find very good application, we take it as the live cell imaging and sensor applications. So all are interconnected. So here I am just going to talk about some of the fluorescent probes recently we have developed for biotoxic analytes or biologically relevant analytes. So, okay. So if this is considered as the different targets, like we developed probes for different types of anions, cations, reactive oxygen species, reactive sulfur species and reactive nitrogen species. And some of our work is related to defense related DRDO. So we develop probes for chemical warfare agents and like sulfur mustard, phosgene and then DCP. and biomolecules. Recently we have developed one probe which can detect the bilirubin within 5 seconds. You know, bilirubin is a biomarker for jaundice. So if normally the existing testing methods take more time, but our fluorescent method is making the detection in a very, very fast method. And some miscellaneous aspects like presence of moisture in organic solvents and detection of pH and hydrazine and so on. So why? What is the need for this type of research? Around us, so many pollutants are there, and we have polluted all the river, water bodies, and every day and morning you would have had a talk about the electrochemical sensors for detection of food additives. So I hope sir might have told about what are all the adulterants present in the food and how to detect them by making use of electrochemical sensors. So likewise, the in and around us, in the atmosphere, in the land and in the water, everywhere we have made our level best to pollute the things. You know the Delhi pollution is how much. So we are living in a polluted world, and knowingly or unknowingly we are inhaling all those things, and these pollutants enter into our body either through food or water or through the air we that inhale. So we need to identify. So already some techniques are available for detection of these things, like various sophisticated equipments are available, like atomic absorption, mass spectrometry, CV, HPLC, NMR, and so on. So whatever techniques that you study in your analytical chemistry paper is all listed here. But can everyone be able to afford for all those things? Though every college is giving a BSc and MSc degree, a student studying in MSc in IIT Madras is able to have an access to all the sophisticated instrument, whereas from a state university, not even a simple salt analysis is a big milestone for them. So the equipment, they need a costlier equipment, and you need a trained analyst, and the sample preparation, everything time consuming. And if at all some institutes, they buy an instrument also, after the warranty is over, then the instrument also gone. So maintenance, running cost, everything is there. So though there are so many equipments available for the detection of these analytes, because of these practical difficulties, we need to have a separate new technique which can be easily affordable by everyone. So here in this aspect only, I am going to tell about something about fluorescence sensors. So they can give a nice color change, which is very much viable and easily visible by a naked eye. And the very high detection limit, they can detect even the levels of the analyte is present in a very less amount, like parts per billion. And they can have a very, very target selective specificity is there. And both qualitative and quantitative analysis is possible, and cheaper device making. And then you can fine tune the molecule in such a way that if you change one functional group into other, it can detect the different targets. So because of all these advantages, we are developing more and more organic molecules for detecting some of these analytes. Though I listed so many advantages, some of the practical challenges that we normally face. Poor aqueous solubility. You know, all the organic molecules are soluble in organic solvents like DMF, DMSO, acetonitrile and so on. But the analytes which are present in the industrial effluents are all present in aqueous medium. So the molecule that you develop should check the presence of these in the aqueous medium. And then complicated synthesis. Morning we had 2 talks, and they were talking about a number of steps of synthesis of most of the biologically active or the pharmaceutically active compounds. And at the end, they may end up with a lesser yield, sometimes an unwanted product may form. So those type of complicated synthesis is involved, and longer response time. They may not give the result immediate, it may take some 10 minutes or 20 minutes, and limited application. And poor selectivity. If many analytes are present, means then the probe is getting confused. and poor fluorescence quantum yield and resolution, poor resolution. Because when it comes to live cell imaging, you need a very good quality imaging is needed. So because of all these things, still there is a need to develop more fluorescent probes for very wide application. Okay, so as the now I am coming to the title. So the title is about donor pi acceptor. So it is like a push-pull strategy. So in a molecule, some groups will be present which are electron donating in nature, and you will also have electron withdrawing, so that the electron flow will be from one end to the other. So you reduce the homo-lumo energy gap, and because of the binding event, there will be a strong ICT or a photo-induced electron transfer, and a visible color change can be occur. So that is why this donor pi acceptor is very much important. So you have a donor group and an acceptor. They are connected by a pi linkage. This pi linkage can be a carbon-carbon double bond or a phenyl ring also. And when the molecule is excited by application or by absorption of photon, then an ICT occurs, creating a push-pull system. So you will have a nice output in the form of a fluorescence enhancement or fluorescence quenching. So what is the advantages? You can easily make molecules, and these molecules will have a very good absorbance in the near infrared window, and they have a strong charge transfer and large Stokes shift. So in the UV and then the fluorescence, if the energy wavelength difference is more, means then it will have a very good application. And you can tune the structure by altering the donor and acceptor unit or changing the length of the pi conjugation. So if you add some cationic species, then it will have more water solubility also. So these are some of the